one of the things I want you guys to see as we go through these is that we're going to come up now with our own similarity statement. Okay? Actually, we don't need to do this one. I'm sorry, I got ahead of myself. What we're going to do is this. This is the next step, if you will, in the natural progression of working with these types of problems. When you're working with similarity, when you're working with the similarity stuff, you're going to be given what's called a similarity statement. It's kind of like a congruency statement, but with similar. So the only thing that differs between the two, instead of having just all parts, corresponding parts being congruent, we have congruent angles, which we know, and then we're going to have sides that have the same ratios. So for every single one of these types of problems, I want you guys to do the exact same thing every time. Yes, it might take an extra second or two to do it this way, but the good thing is that it forces you to do it correctly. Okay? So everybody agree that we have two triangles. Within those two triangles, there are how many sides on each? 3, convenient. Which means there's going to be how many different ratios that we'll write up for the sides? 3. So what we do with this type of problem is we start always by using the similarity statement in writing out the ratios of the side lengths. Now notice how it gives us the ratio, the similarity from ABC to PQR. See how it's going from left to right in the diagrams? So the triangle on the left, where am I going to put that? In the numerator or denominator, you think? Yeah, that's it. Work from left to right. So go through your sides. AB, BC, and CA. 3 numerators. You have 3 denominators. Process of elimination is strong with you today. 3 denominators, PQ, QR, and RP. Which means now I have enough information to fill in the blanks. So what I want you guys to notice here is that this now setup of the lettering is what you were given 2 days ago. You just had to write it down today. That's what's new. You're just writing down the statement. And now you fill in the blanks like you did 2 and 3 days ago. So in our diagrams, AB is equal to, what is it, 14. PQ is X. BC is 6, 9.
Yeah.
And then we do that. What's up? I didn't hear you.
I didn't know. Not again.
Second time.
Is that only the second time that's happened? Yeah, it's after next week. Or we and another 2 days. So we have another 7 days. So in this case here, we wrote out the statement, and now you just solve for x. Does it matter which of the 2 fractions you use to solve for x here? No. Now, if I simplify this, would it just make my life easier?
Yeah.
It would also give me its scale factor. Remember, the scale factor is a simplified fraction. In this case here, it's 2 over 3. I could write it out as 14x is 6 over 9, or I could write 14x is 2/3. Either way is going to work the same. You have a calculator, you press buttons. That'll be able to solve then for the missing value. Yep, fraction equal fraction, you cross multiply. Divided by 2. You get x is 21. It works both ways. Could you have used the, what was it, something over, was it 15 over 22 and a half? Sure, by all means. Do you need to use the ones with the weird numbers? Nope. That's it. So what happens then it's just a matter of writing the fractions down correctly. As long as you do that, write the letters out, everything else is just cross multiply and solve. Okay? Now the only goofy thing that could happen excuse me. The only goofy thing that tends to happen with these is that the diagrams and the statements might say, hey, go from left to right. But sometimes they might ask you for a scale factor from right to left. All you do then is just flip it. That's about as goofy as any of this stuff gets. So another quick example, we're going to use our similarity statement. We're going to solve for, I don't want to use A. We'll use a value of x there. Actually, I probably shouldn't use x because x is,
For lamos.
we'll use w.
Yeah, that's for winners.
Okay. So you're going to use an x? Same thing, exact same thing to start again, guys. We start listing out the fractions. Go through the list, write them out. RS, ST, TR. And we fill them out the other side. XY, YZ, and ZX. And now it's just a matter of what are those values? Well, you look at the triangles, you look at the diagrams, you fill in the blanks. $45, $50, $27, $30, W, and $40. Remember, the similarity statement, the triangle, squiggly triangle, tells you right away that they are similar. There's going to be some common scale factor. The scale factor is the simplified ratio of the sides. 45 over 50 simplifies to be what? 9 over 10. What's 27 over 30 simplify to be? 9/10. It's a good thing it's the same, isn't it? Because if it wasn't, it wouldn't work. Okay. So that tells me you can do a couple things. The scale factor going from left to right, that's how we have this set up. Numerator is in the top on the left, denominator is in the bottom, is 3 to 4. Not 3 to 4, I'm sorry. 9 to 10. That's the scale factor. Scale factor helps you find side lengths faster. What's that? Yeah. So when you're using scale factor, it's an easier fraction to work with as opposed to 27 over 30. Could you use 27 over 30? By all means. You guys all have calculators, so it's not a big deal if you use the larger number. It's easier when you have smaller numbers because a lot of that can be done in your brain. It's hard to believe, but yes. 10 times what is 40?
4.
So 9 times 4 is?
36.
Cross multiply and solve, you get the exact same value.
Thank you.
And that's that. Okay.
Real smooth.
What's that?
Where did 36?
Cross multiply. What's 40 times 9? There's your answer.
Okay.
It's just cross multiply solve. We just did it shorthand because the numbers were nice. 10 times 4 is 40. 9 times what is W?
But what about the 47 over 50?
You don't need to use it. Remember, the 9 over 10 is the scale factor. If you take 45, where's your calculator? You got to get a calculator,
I
man.
never.
You have to have a calculator.
One of these missing together.
Bring $15. We have them here. You got to have one. You have to have one. All right. So in this case, when you cross multiply out, it works. That's all it is. Okay, that's all that is. Now, the only other thing that I haven't talked about yet about what else you can use scale factor for. In similar polygons, the scale factor of the sides is the same as the scale factor of perimeter. It's the exact same thing as the scale factor of perimeters. Okay. The reason why we say this one is because as we get further along in these types of problems, you might be given just a scale factor and you'll have to solve for all the other parts. Or you might be given a scale factor and you have to find the perimeter of something else. So the side lengths have the exact same scale factor as the perimeters do. Okay? They always will. So if you look on the whiteboard on the right, what we did here was those were the two triangles we just had up. The 45, 27, and 36. Oh wait, we didn't do that one yet. I got ahead of myself. So, oh yeah, we did this one, sorry. Excuse me, if I add 45, 27, and 36, you get 108. If you add 30, 40, and 50, you get 120. Throw that in the calculator, and what does it simplify to be?
Hold on, no one said. Let me get my computer.
So you're telling me it's 3 over 2 because 108 is bigger than 120? You can't use it.
So unorganized.
So guys,
Oh shit.
Sorry, I'm bored.
9/10.
again, what letter did you use?
X, because I didn't want to make you feel lonely.
Okay. So remember, when you're dealing with these perimeters, you're dealing with scale factors up here, guys. The perimeter and the side lengths have the exact same scale factor. And what this will be able to let us, or what this is going to let us be able to do is a problem like this, but faster. Let's write this one out. Show you how this works. I want to write this out and walk you through this one because it's going to ask a couple of different questions. So here's our first dab into a polygon that's not a triangle. And in this case, it's a quadrilateral. It's got 4 sides. Which means, how many fractions do you think you're going to write?
4.
4 of them. So just like all the other problems here, what we start out with is the same exact thing. We take the, what's called that similarity statement, where it says A, B, C, D is similar, F, G, H, and J. And we take that first, and we write out the 4 possible fractions. Reason being is because from there, all you have to be able to do is fill in the blanks. Okay? And like I said, sometimes by writing this out, it might take a minute or 2 longer than normal, but it alleviates so much confusion later. Yes, ma'am? All right. So we start the same idea. You just pick AB, so AB. What's up?
If you know, like, what it is already, do you have to, like, go through this whole process?
No, but going through this process is going to help you later, because what happens if I ask you to find HJ, HG, and GF?
Well, which is,
I know where you're getting at, but by writing it out, you're hard pressed to screw up. That's the idea. Okay. Corresponding was what?
GH, bro. Oh, guys.
Okay. Everybody okay with writing out those statements? That's the easy part. From there, it's a matter of just filling in the blanks. Look at what you know. 15. 8. 10. And 12. On the other one, on the other diagram, we don't know what all those parts are. So I'm just going to go X, Y, and Z for those three. So I have X, GH is Y, HJ is Z, but JF is 8. So what you can do here is that you have one ratio set up for yourself. You have to get at least one of them to work, otherwise you know that you done goofed. Okay. So what does 12 over 8 simplify to be? 3/2. So the scale factor here is 3/2. That's going from ABCD to the H or FGHJ. Okay. The question asked you, what is it going the other way? So if I wrote it as my scale factor from the big to small was 3/2, what is the scale factor going from small to big? Flip it. What is it? 2/3. So this is about as goofy as they make this stuff to be, is that they're going to ask you for the opposite scale factor. It's just a matter of reading what you know. Okay? More often than not, I'm hoping that you guys will usually generally go from left to right, and then go back and read the questions. Sure.
ABC is first. J is 3.
Yes, sir. Yep. And it's a very common question. A lot of times, I think even in the homework stuff, it'll ask you for both of them. And it's just a matter of how you write it out first. I'm usually always going to write it out before I do anything, and I usually go left to right. I don't even read the questions until I get to this point. So I got the first one done. The next one says, find the perimeter of the small figure. Well, I can do this one of two ways. We know what the scale factor is, this 3/2. I can set it equal to each one of these three, and then add them all up. Or remember, if the scale factor is for the sides is the same as the perimeter, why not just figure out what the perimeter is for this? And then you can figure out what the perimeter is for this one. The perimeter of the ABC one, well, 12 and 8 is how much? Add 10 you get? Add 15 you get? 45. So this one is the perimeter of the top of the numerator is 45, which means I can find the perimeter of the other just by doing that.
What would you use for your activity?
Depends on how you wrote it. I wrote my scale factor down originally going from left to right. So I'm going to use it as 3/2, which means the bigger one is in the top, the smaller one's in the bottom. That's about as goofy as this gets. You have to be consistent with what you're writing down. Okay? So very, very fast cross multiply here. You double 45, you get 90. So the perimeter of the small one is 30. It did not ask for you to find all those individual sides, but you could have, just by redoing it out. It's just depending upon what the question is asking. Okay. Does that make sense? Now, really the only other part of this stuff is this last one. Where, well, first of all, let me have you guys take a minute and figure out the scale factor and the perimeter, and then we'll talk about how you figure out the other corresponding parts within. So take a minute, do all the steps that we just did. Yeah, it's a shame that we have to do that stuff.
Wait, do what?
Intruder stuff. I hate the fact that we have to even think about it, but it's a crazy world.
Wait, did you not have to do it when you're younger?
I want to finish.
So there's our first 5 side lengths for the one on the left. We write it out the fractions to get to the one on the right. Same deal, write it out. Hey guys, I really cannot stress the importance of taking 2 minutes and writing these things out. I know it takes more time, it takes up space, but you have to believe me that it forces you to do it correctly, okay? It really does. So now you fill in the blanks. We got 14, 12, 16, 12, and 8. I know that they're going to ask something about perimeter, so I'm going to do another one here for perimeter on the left over perimeter on the right. See what I'm doing? I'm just putting what are called subscripts. Subscripts are like an exponent, but written a little bit below. It's kind of like how you do points, x sub 1, y sub 1, things like that. I'm just saying perimeter for left, perimeter for right. It just thinks that they have the same letters, but the perimeter on the left, let's see here. 12 and 8 is 20. 14 and 16 is 30. So there's 62.
I mean, wait. How did I keep
Here's
that up?
20, 30.
I said.
So that gives you 50. So then I have 62.
Yeah.
So it'll be a 62 here. Now, we know one of them. We knew that TU was 20. So you can do one of 2 things. You could find each of those other 4 side lengths, but since it doesn't say to do that, don't. Use the scale factor to find the perimeter. What's the scale factor going from left to right? Yeah, the scale factor from right to left is 5/4. Left to right is 4/5. And then you're right. The question asks you going from right to left, so my answer would have been 5/4. The perimeter then, I take 4/5 and I set it equal to 62 over something. Cross multiply that. Excuse me. What do you get? 60. I think it was 65, wasn't it?
Oh my gosh.
It's 77 and a half.
Yeah, that's what I got.
So it gives me a perimeter. I remembered it the first hour. It gives me a perimeter then of 77 and a half. Now, the other question asked me, what is the corresponding diagonal? So remember, whenever you're dealing with similar figures, all the corresponding parts are going to have the same ratio. You know that the one diagonal SU is 25. That one is on the right, so it is a denominator. This one's on the left, it's a numerator. So you use your 4/5 is something then over 25. That's it. The corresponding parts are also have the same ratios. It's just a matter of filling in the blanks. Knowing whether it's a numerator or a denominator. Is it on the left or is it on the right? It's 20. Okay. Are we okay with that? That's quite literally the only other thing that we have to show you. I have to show you guys how to do. Yes, ma'am. Oh.
So are we moving at the right pace or?
Yes, sir.
Extend the pace.
What is under the 4x? I could do that.
4.
Backwards 3.
It's
Well, it's the 4.
I don't remember asking you.
And then you can that's perfectly fine.
Actually,
I have no problem when you go through that route. I'm showing you the way that if you do it this way, it forces you to actually write it and show it, that we don't screw up, that we don't accidentally do something silly. That's all. If you pick up on it, I will never say no, you can't try and find your own shortcuts. I just hope that you make sure that they work. That's all.
Shut up. 25.
Guys,
Put some seasoning in it.
Oh, shut up. Really.
you can't. You gotta make sure you're multiplying the right values. That's all I'm getting. By writing out the lettering, it forces you to know which one goes where. That's all it is. But you're not.
Why are you so many little things?
We okay? Alright. Same page. Add these to your problems. What is it? 376? Is that right? I was close.
Oh my god.
Better than 20.
367.
So 9 through 12. I was right.
Oh my god.
Add those problems into those two you started with. You guys have a few minutes to start up on it. I expect you to start on that, not getting up and wandering around and talking to each other. I expect you to be seated until that bell rings. Go ahead and get started. On Monday, we will start then with the actual just working with triangles as opposed to polygons and triangles, okay? Excuse me.
I feel like I already had help. But I thought. Yeah, are you ready to take that test?